Hello, drawing students. This is a continuation of our perspective lecture, and we're going to talk about 2-point perspective to get ready for Wednesday. So, this picture should look familiar to you. In 1-point perspective, we were looking at this directly. Now we're no longer doing that. We are looking at it on an angle. So now what we have is called a leading edge. The leading edge is a perfectly vertical line. All vertical lines in 2-point perspective are perfectly vertical, but we no longer have horizontal lines. We only have vertical. We have vertical lines and we have converging lines that converge to one of 2 points, because again, 2-point perspective. So all lines that converge towards the left side for you, I think that's what this is. It might be your right. It's my right side. All lines that converge towards the right side converge at vanishing point right. All lines that converge towards the left side converge at vanishing point left. There are no horizontal lines. This is no longer horizontal. It is now at a diagonal that is going to a vanishing point. We only have vertical lines, and those vertical lines are perfectly vertical. So you're still using that drafting triangle to line up your ruler and make sure it's perfectly vertical. Okay. 2-point perspective, where no planes of the form are parallel to the picture plane, an edge of the form is closest to the picture plane. So that's when one edge is closest to you, and that's what we call the leading edge. We still have an eye level and a horizon line. You will always have an eye level and horizon line in perspective, and that is where your vanishing points exist. We have vanishing point left and we have vanishing point right. The cone of vision still goes through those 2 points. Okay? So you cannot draw outside of those vanishing points lest things get distorted. So when we go to draw in 2-point perspective, we were able to, in 1-point perspective, we were able to find the exact dimension of a perfect cube because we were able to use these points as a way to measure, to get diagonal measuring lines from. We're not able to do that in 2-point perspective. There is a way to find a perfect cube in 2-point perspective, but it is slightly too complicated to do that, or to teach that in one class, so I'm not going to. But what I want you to do and what I want us to practice is estimating the depth of cubes. So, which is difficult to do, and that's okay if you don't get it perfect. But the one thing I really want you to learn is how when things move from, that's why this CVP is labeled, when things move from the left or to the right of the center of your drawing, or from where you are standing, say there's a imaginary vertical line that is derived from the middle, like goes between your 2 eyes and divides your picture plane right in half, right? There's this imaginary line right there, imaginary plane. As things move to the left or to the right of that imaginary plane, you start seeing more of one side or the other. Same thing with 1-point perspective, how I was showing you that, but even more so in 2-point. So when we go to estimate the depth of our cubes, notice how we see the more it moves to the left side of the picture plane, so say this because this is where vanishing point left is, the more of the right side of that object you see. So that means that when we go to estimate the depth of that cube, we're going to estimate a longer dimension here and a shorter dimension here. Same thing for the opposite. When we move farther to the right side, we're seeing more of the left side of the object and less of the right. So when we go to estimate the depth, we will start by making this line longer than this side. And that dimension, dimension ratio is more and more exaggerated the farther away you get from your central vanishing point, or your central, that imaginary plane right there. Right directly in the middle of your eyes and down. Notice this cube where the leading edge is directly in line with the CVP, or that imaginary vertical line. that divides the picture plane in half, this is right in line with it. So the dimension of the sides of this cube are exactly the same because you're seeing equal parts of both sides of this cube, okay? And again, what I want you to notice is how these planes get wider as they are farther away from the horizon line and shallower as they get closer to the horizon line. Right here, one of those planes is just a horizontal line because it's completely flattened. But the farther away we get from the horizon line, the wider those planes become because you're seeing more of. If we get a chance, we will draw some ellipses on the side of cubes. The premise of finding the adjacent points, remember there are 4 on the outside and another 4 on the diagonals. The 4 on the diagonals are not absolutely necessary that you find, but they are there for your help if you need them. The same is true on planes that are vertical. So by that I mean this would be a horizontal plane, so this top of the cube is a horizontal plane because it's going back horizontally. This would be a vertical plane, and this would be a vertical plane, right? Vertical plane, horizontal plane. So the same rules apply for doing ellipses on the tops and bottoms of things as well as the sides of the cube. That just means that it's wider. So maybe there's like a cup on its side, right? Or a cylinder or something like that. So this is just the cubed version of this square that we went over in the ellipse assignment. This is something that I think I put on the ellipse assignment page, but I wanted to show you this again. Remember, as planes get farther away from the horizon line, the deeper those planes are, okay? So planes being a flat surface is all that planes mean. If that's confusing you and you think I'm talking about airplanes, no. Planes meaning flat surfaces. So the farther away they get from the horizon line, say that this horizon line is, it goes this way, the deeper those get. What this plus sign is representing is the middle of the perspective drawing. So this horizontal part of that plus sign is the eye level. This vertical line is going straight vertically through the central vanishing point, or the central point, the central vanishing point, or the imaginary vertical line that goes between your two eyes, right? So the farther that they get away from the horizon line, the deeper they are. Same is true for vertical planes. The farther they get away from the center of the drawing, from the center of your viewpoint, the deeper those ellipses get because the more of them you are seeing. So the closer they are to your center, right, the shallower they are, and sometimes they are a single line, which is probably what that plus sign is right there. Okay, which one of these is correct? I can't hear you. Oh. So, technically, this one is correct, but if it was a clear glass and it was raised above you, this would be correct. But for your typical drawing where you're looking at a cup on a table, this is going to be correct because you're looking above the cup. So your eye level is up here. The ellipse on the top is shallower than the ellipse on the bottom. The only way that this makes sense, it does not make sense as it's sitting on a table in front of you where your eye level is up here, because this ellipse is deeper than this one, so that is opposite. So the only way that this works is if it is above your head and your eye level is down here. Remember, because the ellipse is closer to the eye level, must be shallower than the ones farther away. Vertical traces. Vertical traces go up vertically through vanishing point left and vanishing point right. And say you're drawing a box. Well, every plane on that box obeys perspective. So where these lines are derived and their vanishing point has to be sighted, because this could change. Like the flap of this box could change just slightly, then this vanishing point has to move. So what this A is for is alternative vanishing point. And these are all sighted, but they do exist on the vertical trace, which is derived from the vanishing points. Again, don't get too confused. Same is true for the tops of houses, the roofs of things that are on an angle. They obey perspective as well. Again, these angles are sighted, and where they intersect the vertical trace that goes through vanishing point left and right, that is their vanishing point on the vertical trace. Same thing for the rise and run of stairs. So you determine the rise, you determine the run that you want, and from this point to this point is this vanishing point, and then you go up vertically from there and this point to that vanishing point that you just derived. That determines where the rise and run of each of your stairs is, and this line goes to vanishing point right, the front planes of the stairs go to vanishing point left. You can pause and look at that for a while if you want. We will not be doing stairs. Don't freak out. Okay? It's okay. I do want you to look at this though. If we did have time, we would do this, and that is where this is called transparent construction, geometric solids inside of cubes. Again, remember, everything is derived from the cube. Everything fits in a cube. Your head fits into a cube, right? Or stacked cubes. The figure fits into stacked cubes. So we can, because we know how to draw ellipses on flat planes, we can, once we have the cube drawn, we can draw the bottom of a cone. We can find the middle of the top plane, and that's the point. And we go from the most exterior side of the cone here, and the most exterior side of the ellipse here, and that is a cone. You can draw a wedge if we want. Use two ellipses on the top and bottom and draw a cylinder by drawing a vertical line from the most exterior part of that ellipse on the top on each side, and that's a cylinder. You can draw arced things by only drawing half of an ellipse on one side of a cube. Oops, I accidentally touched the screen. So you can draw arced things, right? By using what we already learned about drawing ellipses and only drawing the half of it and going down from there. Cool. So just some artists who use perspective. For those who think that this is outdated, it's not. It will make a comeback. Again, there used to be years of school of art schools where they had semesters dedicated to perspective because how important they felt that it was. But the pendulum has since swung back to not being important anymore, but I am carrying it on. It is important because all things exist in perspective. So this is Julie Moretu. She takes the rules of perspective. She obeys them sometimes, but then she abstracts them sometimes. She makes abstracted drawings and paintings that are reflective of the order and chaos that is life in society, especially now. Oh, that's a grainy picture, but she, I love her work. She, incorporates all these different planes. Like, look, this is a plane that's obeying perspective. These are all planes that are obeying perspective. Now, she's making a lot of it up, except for, you can see right here is a ground plane that we just talked about. There's a vanishing point right here that she's getting all that from. You can see all of the detail work. There's like this really thin lines back here. Do you see these arches? That's all obeying perspective. So she's just layering perspective. And in that, she's layering realities. And then she's abstracting it. This was my drawing 1 and 2 professor. His name was Nate Hoyer. Drew kind of dilapidated buildings. Pretty cool. They're very detailed and very large. Uses watercolor too. I believe color pencil. Very clean. But he takes a lot of time. He's got a vanishing point over here. He's got a vanishing point over here. His leading edge of his building is right here. And look, he drew all these stairs in perspective, the railing, everything obeys perspective. The columns have thickness to them. That's very important. We're not drawing flat things. We're drawing things that, on Wednesday we're just drawing from imagination, but for your assignment you will be drawing things that you're trying to make look real, and those things need to have thicknesses. So you're repeating that plane and going back in space with that just a little bit to show its thickness. And even the brick back here, he's using perspective. I know you can't see that, but every brick back here obeys perspective. And then these are my drawings. I started drawing burnt down houses for my family, childhood neighborhood. And so, yeah, so it obeys perspective. All the brick on the chimney obeys perspective. The leading edge of this house is right here. And I derived the sighting of the house from a vanishing point over here and a vanishing point over here. Same with the railing on the porch and the stairs here. And then this one, there's a vanishing point way the heck over here. So some more dilapidated, burnt stuff. And then, this goes back. There's rungs here, like the walls of the house that you can see inside of. They're over, that vanishing point is over here. And then last one, this was basically just a pit that I found, that it was a house. This was the framing for the basement. But anyway, so it is very much still alive and will never die. That's my point.